Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. H.P. Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the today's discussion will be about the construction of the isometric projections of a pentagonal prism. Now we are going to discuss the two orientations of the pentagonal prism with respect to the reference planes, horizontal plane and the vertical plane. Now in the first orientation we are going to construct the isometric projections of a pentagonal prism which is resting on its rectangular face onto the ground with its axis parallel to both HP and VP. Whereas in the second case we will be drawing the isometric projections of the pentagonal prism which is resting on its pentagonal base onto the horizontal plane, and the axis of the prism will be perpendicular to the horizontal plane. So let us start with the first construction to begin with. Now here we have a pentagonal prism of base side 25 millimeter and axis length equal to 60 millimeter. It is resting on its rectangular face onto the ground with its axis parallel to both HP and VP. So we are required to draw the isometric projections of this solid. Now here first of all we need to draw the basic shape of the pentagon, which will be a geometric construction. So here we will have the H equal to 25 millimeter. External angles everywhere they will be 72 degree. So we get edge length is equal to 25 mm, and once we complete the construction of this pentagonal shape, then next we have to inscribe this pentagon within the rectangular shape, because we know that into this pentagonal shape there will be only one edge which will be resting upon the isometric axis, whereas the remaining four edges, that is 1, 5, 4, 5, 2, 3 and 3, 4, they are all non-isometric edges, or they are lying onto the non-isometric lines over there. So we cannot draw all of these edges straight away onto the isometric projections. There we have to measure the rectilinear distances between different points, and we will be able to work out the locations of all these points, that is points 3, 4 and 5. Similarly, regarding the axis over there, we need to evaluate the axis of this pentagonal prism, and for that what we have to do, we have to obtain the midpoint of all of the edges of this particular pentagon, and then from every corner, you see, minimum 3 perpendicular projections you need to draw. You can draw all 5 or even 3 are also good enough. So please check, from point 4 I have dropped a perpendicular bisector onto the edge 1, 2. Similarly from point 2 I have drawn a perpendicular bisector onto the edge 4, 5. Right? Similarly from the corner 5 I have drawn a perpendicular bisector onto the edge 2, 3 over here. So wherever all these bisectors they are going to meet, so we are going to obtain the axis points O and O1, which will be located on the two end faces of the prism over there. And once we locate this axis point, one thing we should note, that this axis point will be lying slightly below the horizontal line which is going to join these 2 points 3 and 5 over here. Another thing, we cannot locate these axis points straight away once again onto the isometric projections, because the angles and the shapes they are not going to be preserved in the isometric projection. So what we have to do, once again, since we have inscribed this pentagon into this rectangle ABCD, so once again from the corner of the point A of this rectangle we are going to measure the distance of point E. So one center line will be located over there. Similarly from point B or from point A we will be measuring this distance, this distance is equal to BF, right? So this is my locus line corresponding to BF. So once I measure this point, so once again a center line will be located. So wherever this center line and this center line they are going to intersect, I am going to obtain the location of the axis point O or O1 into the pentagonal prism. Now once we have to start with this construction of the isometric projections, we must draw this isometric scale, right? So before starting with the construction of these isometric projections of the pentagonal prism, the first thing we need to carry out is construction of this isometric scale, and then all these dimensions, that is rectilinear dimensions, they will be first of all marked onto the true scale over here, and then these will be converted onto the isometric length, and all those distances of isometric length will be drawn onto the isometric projections, right? So let us start working out the isometric projections of the pentagonal pyramid. So we draw the horizontal line or the ground line, then we'll be marking a point over here on the ground which will be our starting point, and from this point we are going to draw the x-axis inclined at an angle of 30 degree and the z-axis which will be drawn at an angle of 30 degree over there, and the height will be shown along this y-axis. Okay, so now since this pentagonal prism is resting onto its base, onto its rectangular face over there, so this is the rectangular face 1 2. So this would be lying over here onto this line, onto this x-axis. So what we are going to do, we have marked the height, and how much this height is equal to, this height, it is equal to this edge y of this rectangle which we have drawn to inscribe this pentagonal shape over there. So this shape we are going to draw from here. So this we are going to assume this will be our front view over here, right? So this shape A, B, C, D, so this will be drawn along XY plane over there. So this is my X plane, this is my Y plane, and this length of the axis will be drawn along the Z axis in this particular case. So let us make the measurements. So first of all you can check, this is my distance X over here. So this is X, X means this is the longer edge of the rectangle which is inscribing this particular pentagonal shape over here. Now X is the longer edge and Y it is going to be the shorter edge. So X we have drawn, please check, I have marked this longer edge equal to X, and the shorter edge of this rectangle we have marked as Y. So we can check that this longer edge first of all we have drawn onto the isometric x-axis, and we have marked this Y edge that is corresponding to the edge BC onto the isometric axis in the Y direction. Then these two isometric lines they have been drawn such that this line represents the edge DA, and this has been drawn parallel to the y-axis, and the height of this edge will also be equal to y. Similarly, this is the edge which is again the isometric edge, and this has been drawn parallel to the isometric axis over here, and the length of this particular edge is equal to CD, and CD is equal to AB which is equal to X over there. So this face of the rectangle we have drawn in the first phase. Now we know the length, this is the length of the axis which is equal to 60 millimeter. Now I am going to draw 60 millimeter along this particular direction. So along the Z axis I have marked this distance is equal to 60 millimeter. So this is drawn onto the Z axis, and this is another edge corresponding to the top face which we have drawn parallel to the isometric Z axis. And now we can complete the other two isometric edges which we can draw. So this edge is parallel to this one and parallel to this one. Similarly, this edge is parallel to this one, and again it is parallel to the x-axis. Now we have to complete those edges also which are not visible, because we have to complete this pentagon construction. So again we have drawn this light. So again draw this distance is equal to y, which will be parallel to this vertical edge, this vertical edge and this vertical edge. And how much will be the length of this vertical edge? Again equal to y. Now next I am going to join this face, so that this edge I am going to draw parallel to this one and the x-axis over there, so that my rear face, this is my front face of the pentagonal prism. This is the place where the rear face of the pentagonal prism will be drawn. Next I am going to join this edge, which is again not visible to the observer because this has been overshadowed by these three faces. So face 1, face 2 and face 3, they are going to cover this edge and this edge. So since these edges are not visible, so we have shown them with a different color over there. Now having drawn one rectangular face in the front view over here, and this is another rectangular face which is corresponding to the rear end of this pentagonal face, right? Now we are going to draw the points, that is A, B, C, D, which corresponds to this point A, B, C, D. So AB is the longer edge and BC happens to be the shorter edge. Similarly on the rear side also, the corresponding we have added a suffix 1 over here. So this point is A1, this is B1, this is C1 and this point stands as D1 over there. Then the next thing is evaluating the axis point in the front face and evaluating axis point in the rear face. So in the front face, how I have located this axis, I have measured the distance, please check. I have measured the distance between corner A and this point E, right? So this was there in the geometric construction. So this distance, once again all these distances they are isometric. So this distance of AE, so this isometric distance I am going to mark over here. So this will give me point E. Similarly B to F, I know this distance from the geometric construction. So once again the isometric distance will be converted and this will be my point F over there. So this way points E and point F, they have been located with respect to once again corner A and corner B respectively. So this horizontal distance is with respect to corner A, this vertical distance has been marked corresponding to the corner B. So again rectilinear distances they have been marked to obtain the center point in the front face. So here we get the access point for the rear face as well. So similarly from A1, so the distance of E1 is marked. Similarly from B1 the vertical distance of point F1 has been marked over here, right? So we get access point in the front face and access point in the rear face. Now we are going to mark all these 5 points. So these are the 5 points of the pentagonal face over there. So 5 points corresponding to the front face will be there and 5 points corresponding to the rear face will be there. Then we will see which are the edges which are visible and which are the edges which are not visible. So this is the, please check, distance of point 1 from point A is this much, and this distance is equal to distance of point 2 from the corner B. So distance of point 1 from point A will be this. So I am going to mark this distance. Similarly, it is equal distance over here. Distance of point 2 from point B will be equal to distance of point 1 from the point A. So the 2 points they have been marked. Next, third point. So third point is 3. So you note down this vertical distance from corner B related to point 3. So measure this distance B3. Again evaluate the isometric distance. So B3 is evaluated. Similarly, B3 is equal to A5. So this is the same distance. So if you want to measure, you can measure. Otherwise, mark the same distance as B3. So B3 is equal to A5. So fourth point in the front face has been evaluated. Fifth point, it is practically the midpoint, but still you can measure the distance C4 over here. You can measure the distance C4 or D4. So you can measure this C4 or D4, but it will be lying on this axis line or the center line. So we have evaluated all the 5 points in the front face. Now let us repeat this procedure for the rear face. So distance of A1 11 is equal to distance of B1 21. Similarly, distance of B1 and 31, this will be equal to B3 distance, and similarly A1 51 distance will be equal to B1 31, which will be equal to the same distance of A5 or B3. And finally 41 you can locate at the midpoint of the axis over here of this H, or you can locate it distance of 41 from C1 will be distance of C from 4. So all the 5 points in the rear face, all the 5 points in the front face, they have been located. So let us join the relevant points which are visible to the observer. So as the observer is going to look at this particular prism from the front side, so all the points of the front face will be visible. So I am going to join all of these edges of the front face darkened over here. So please check, all the 5 edges of the front face, they have been joined dark. Similarly, now the observer is able to see this edge 2 2 1, this is visible to the observer. Again 3 and 3 1 will be visible. Similarly 4 and 4 1 will be visible, but then and similarly 1 and 1 1. So these two edges will be covered by these faces. So let us join them. 4 and 4 1, they are dark. 5 and 5 1 visible. Then you have this edge 4 1 5 1, 4 1 3 1, and then 3 and 3 1, and again this one also visible. And now you can see these edges observer can see, but this edge 1 1 5 1 and again 1 1 2 1 observer cannot see. Similarly 1 and 1 1, so these three, right? So this is 1, this is 2, and this is 3. So even if we are not showing these 3 edges over there, still the construction of the pentagonal prism will be all right. But once we have shown all these edges appropriately joined with each other, so this gives us a proper feel of the pentagonal prism which has been constructed over here. And please check, I have joined 1 and 1 1 with a lighter line, construction line. 1 1 and 5 1 have been joined with a construction line, and 1 1 and 2 1 has been joined with a construction line. So we did not join these edges with dotted line. There is no space for dotted line or a hidden line in the isometric projection. So either we have to join it dark or you leave it otherwise. But we have joined it with a construction line so that we get a feeling that these are all the edges which are available on the rear face and the front face over there. So this completes the construction of the pentagonal prism which is lying on its rectangular face. Now next we are going to move on to the second orientation, that is when this pentagonal prism is resting on its pentagonal face or its base onto the ground, and the axis of this prism will be perpendicular to the horizontal plane. Again the dimensions remain the same. Base side 25 millimeter, axis height 60 millimeter. So once again we are going to repeat the geometric construction of this pentagon. We'll work out the evaluation of the axis points, that is by drawing from every corner perpendicular bisector of the every edge, and then wherever these projection lines they are going to join, we are going to get the location of the axis points O and O1. And after drawing this pentagonal shape, the geometric construction, then we will be inscribing this pentagon into the rectangular shape over here, because these non-isometric lines cannot be drawn onto the isometric projection. So we are going to transfer all these points using the rectilinear distances. So AB, it is the longer edge of the rectangle which is going to cover this pentagon, and then the BC is the shorter edge which we have called as Y. So we have two dimensions, X and Y, corresponding to this pentagonal shape of the base, and the axis height will be 60 millimeter. So please check what we are going to do. First of all, step number 1, it is the construction of the isometric scale. So the true length will be marked at an angle of 45 degree. Isometric length will be marked at an angle of 30 degree. Then all the distances of the true length, they will be translated or transformed into the isometric length distances. So all the distances of this problem over here, so initially they will be measured true length, and then these true lengths will be converted into isometric lengths over here using this isometric scale, and only thereafter these distances will be drawn onto the isometric projection. So in the isometric projections, what we have to do, draw the ground line or the locus line first of all. So this is our horizontal ground line. We are going to mark a point over here, starting point, and corresponding to this starting point we are going to mark our x-axis at an angle of 30 degree, and the z-axis we are going to draw at an angle of 30 degree. Now since this prism is standing upright and it is standing tall onto its base, so this base shape, that is this rectangle of ABCD, this will be marked along this plane, that is X and Z, right? So on one of these axes I am going to mark the X dimension, and on the other side I am going to mark the Y dimension. So this is the longer edge, you can check, this is the longer edge. So this is where I have marked the larger dimension of the rectangle. This is my shorter dimension, so this is the place where I have marked the shorter dimension of the rectangle. So this rectangle, which is going to contain the points of this pentagonal shape or the base, so this has been drawn onto the ground, that is, it is resting onto the horizontal plane, right? So all the 4 points we have located corresponding to the base rectangle or the base shape of this pentagonal base. So please check, point A, point B, point C, and point D, they have been marked over here. So the base shape has been created. So once you create a base shape, now the axis height, that is equal to 60 millimeter, we are going to mark from all the 4 corner points A, B, C, D, so that we are able to obtain the top face of this pentagonal prism. So this is the second vertical edge corresponding to the height of this axis, which is equal to 60 millimeter. So height of this axis is given to us 60 millimeter. Now from the third and from the fourth also, right? So all the 4 vertical edges have been drawn, and correspondingly these isometric lines, so these 2 isometric lines and this one, they are all parallel to the x-axis. Similarly, these 2 isometric lines as well as this one, it is again parallel to the isometric z-axis, and then this isometric, this one and this one, they are again parallel to the y-isometric axis. So this is the construction of a rectangular prism, and within this rectangular prism we are going to mark all these points corresponding to the pentagon prism, and then we will be obtaining the construction of the pentagonal prism with the help of this rectangular prism. Okay, so this is our, you see, guiding figure. So the guiding figure happens to be a rectangular prism, right? Now corresponding to the top face, once again 4 points A1, B1, C1 and D1, they have been marked. So the bottom face has been drawn, top face has been drawn, and these are 4 rectangular faces which we have worked out, right? So these are 4 vertical rectangular faces. Now we are going to mark the axis. So how do we mark the axis? We measure the location or the distance of point T with respect to corner A. So this distance we measure, we have marked this distance over here, distance of point E from corner A. And similarly from point B we have measured the distance of point F. So from the corner B, please check, from this corner we have measured the distance of point F and marked it over here. So the access point at the base has been evaluated. Similarly at the top face, again distance of E1 from A1 has been measured and marked. So the first center line has been drawn. Similarly, distance of F1 from B1 has been evaluated and it has been appropriately marked on the top face. So now the second center line has been obtained. Now this is my access point corresponding to the top face. This is my access point corresponding to the bottom face or the base of this pentagonal prism over there. Now the center points have been located. The top face, bottom face has been worked out. Now we are going to mark all these 5 points right onto this rectangular shape using the principles of rectilinear distances over there. So we are going to measure the distance of A1 and B2. So A1 is equal to B2. So we'll be measuring these two isometric distances. We'll be marking it over here. So please check. Point 1 distance from point A, point 2 distance from point B has been measured and marked on the bottom face. Similarly, on the top face also, A1 and 1 distance has been marked and B1 and 2 distance has been marked because both of these distances, they are equal, right? So that is why we are having parity over here. Then next distance is B3. So please check, we have measured this distance from this figure. This is our helping figure, basic figure, geometric figure. So using this distance, again the isometric distance has been evaluated and marked over here. And this will be lying above the axis line. This will be lying above the axis line. Similarly, distance of B1 and 3 has been marked and this distance will be over here B3, right? Then we have marked point 4. So point 4 will be distance of C4 or D4. Actually it lies on the midpoint. So straight away I could have drawn it over here without any problem. But you can measure the distance C4 and D4 over here, right? So point 4 has been marked on the bottom face and it has been marked on the top face of this pentagonal prism. And finally point 5 over here and point 5 over here will be marked. Now this is the point 5 and this distance is equal to A5. So we measure the distance A5 right here and then plot it over here. Similarly, distance of A1 and 5 will be marked onto the top face. Now all the 5 points of the top face have been evaluated. All the 5 points corresponding to the pentagonal shape at the base of this pentagonal prism have been evaluated. Now let us work out which of the edges will be dark, which of the edges will be dotted. Now please check. Top face will be visible to the observer without any problem. So all the edges of the top face, they have been joined dark using the object lines, right? Darker line. Now which are the vertical lines, vertical edges which will be visible? Please check. 1 and 1, this is visible. 2 and 2, this is also visible. 3 and 3, this is also visible. But 4 and 4, it lies behind, so it is not visible. 5 and 5, again it lies behind these 3 edges, so again this vertical edge is not visible. Similarly, from the front, edge 1 2 will be visible and 2 3 will be visible. So rest of the edges, you can see now, this edge and this edge, these 2 edges of the base, they are visible, but this edge, it has been covered by this face. This edge, it has been covered by these 2 faces, and again this edge, it has been covered by this face over here. So on the base, 3 edges will be lighter one. They will not be dotted, they will be hidden edges basically. So we have to draw them using construction line. So there is no space for the hidden lines over there. So we are not going to draw any dotted line. So instead we have to use the lighter construction line. So you can check that in this construction there are 5 lighter lines over there, or 5 construction line. 3 edges of the base, they are not visible. 3 4, 4 5 and 5 1. And 2 vertical edges of this pentagonal prism, they are also not visible. 5 1 and 5, 4 1 and 4. So we have shown all these edges. Why? Because we want to get a proper feel of this pentagonal pyramid. Otherwise, if I just delete these edges, I don't show these edges, still my construction be considered to be complete over there. So no hidden lines, no dotted lines have to be drawn over here. So this completes the construction of the pentagonal prism, which is lying in its upright condition, which the axis is perpendicular to the horizontal plane, and this prism is resting onto the ground on its pentagonal base over there. So the top face, all the edges are visible. In the bottom face, couple of edges they are visible, but the remaining 3 edges they are not visible. So 2 of the vertical longer edges they are also not visible, whereas you are able to see the remainder 3 edges of this pentagonal prism, which is lying in its vertical orientation. Earlier one was the horizontal orientation, right? So this is all about the discussion regarding the construction of the isometric projections of the pentagonal prism, which is lying in different orientations with respect to the reference plane. So we will be continuing with further discussion regarding few more cases of isometric projections in the coming lectures. So this is all for today. Thank you very much. Thanks a lot.